Hi everyone. In this video, we are going to see about the active aerodynamics. So let us detailly discuss this topic in upcoming slides. So what is meant by active aerodynamics? So before going into that, we should know what is meant by aerodynamics. So aerodynamics, it is nothing but overcoming the air resistance to the vehicle motion in an effective way so that it enhances the fuel efficiency, the mileage, and etc. etc. So normally here this aerodynamic term, this particular thing is taken from the aircrafts where they use a aerofoil shape in front side of the vehicle in order to just make the air to move away from the motion of the vehicle, just laying the pathway for the vehicle just by cutting down the air resistance in an effective way. So the same thing that has been followed in automobile also, where the front portion of the vehicle is made in the shape of an airfoil or uh, different types of an airfoil structures. So the main motive behind that particular thing is that to overcome the air resistance in an effective way. Because if we use the square type or a box type, which has been used in the traditional commercial vehicles in earlier days, it doesn't provide that much aerodynamic property where we can lose the mileages and it reduces the fuel efficiencies. So in order to overcome that, the aerodynamics has been applied in the vehicles. Normally, we can experience this particular aerodynamic during high speeds. In speeds like 30 or 40 or 50, we cannot observe the aerodynamic property that much. It is normally used in high-end cars or high-speed cars. So when we cross across 80 to 90, from that to more than 90 kilometer per hour, we can just observe the real working of this particular aerodynamic properties. So there are many aerodynamic forces and moments that will be involved to the vehicle motion. So while designing a vehicle, the engineer should consider these all forces and moments, and according to that, he should fix the aerodynamic components in order to reduce the drags, increase the downward force, and improve the stability of the vehicles. So this is normal aerodynamics. So what is active aerodynamics? So active aerodynamic is that in case of aerodynamics, we use many components like spoilers, flaps, vents, etc. etc. So it will be in a stationary condition. Here in active aerodynamics, it can be movable and it can be moved according to the environment, according to the requirement. It just shift its position automatically in order to have a good aerodynamics. So that is the active aerodynamics. So here the dynamic components include movable spoilers, flaps, vents. So it can be moved according to the real-time conditions. So it improves the performance, and airflow optimization also can be done. So this is the pathway of this particular aerodynamics 1986 in Porsche. So it's one of the production car featuring the active aerodynamic components. And in year 1988 to 1991, the Volkswagen Corrado and Mitsubishi, where it has been used. And today it becomes a standard technology. It is used in many luxuries and sports cars and high-end sports cars, and now in EVs also. So in this slide, we'll discuss about the example, the Mercedes-Benz CLE Coupe, where this active aerodynamics has been used. So it deploys at high speed for enhanced stability and retracts during the city driving. So as I said earlier, this particular aerodynamic forces, that this technology it is needed only in the high speed conditions. And streamlined designs and smart adaptation, it makes this car more and more worth and produce a good riding in the high speeds. And Hyundai and Kia are revolutionary in active ASCAR technology, where it obtains the speed activated deployment, performance enhancement, the range extension, and the intelligent retraction below 70 km per hour also to prevent the damage and unnecessary operations. So these are some key active aerodynamic components: the adjustable rear spoilers, air brakes, and active grille shutters, which is placed in the front of the vehicle, which also serves as a cooling system to the engine radiators. and active underbody management in order to safeguard the batteries, and also provide a good aerodynamic property to the vehicle by managing these underneath forces. So this transformative benefits of aerodynamic includes the 20% braking distance reduction and 15% fuel efficiency improvement and 25% downward force enhancements. So this is the chart of various countries showing their market trends and growth outlook in the active aerodynamics. So the future of this particular active aerodynamics is that the morphing surfaces, AI integration, and the urban air mobility. So this mostly deals with the aircrafts, and some of them that can be also be used in automobiles. So this is the road ahead with the aerodynamics. It includes the transforming the vehicle design according to the next generation requirements, and also it will plays a vital role in the Indian automotive future, and also it just paves the pathway for the innovation uh, in the vehicle, especially in EVs. So that's all about this active aerodynamics. Thanks for watching my video. Thank you.